This video is about the Pythagorean theorem and how to use the converse to classify triangles. So the Pythagorean theorem, remember, only works for right triangles. And in the Pythagorean theorem, we have c squared, which represents our hypotenuse squared. Remember, the hypotenuse is always the side across from the right angle, is equal to a squared, which is a leg, plus b squared, which is a leg. So we're going to take always the hypotenuse and put it by itself, and the legs are always together. So let's use the Pythagorean theorem to find the missing variable. So number one, we want to find CD, which is x. Well, x is across from the right angle, which means that x is the hypotenuse. So we would have x squared equals 12 squared plus 5 squared. Make sure that you're squaring the numbers first. So we get x squared equals 144 plus 25. When I add those together, I get x squared equals 169. So I'm going to take the square root of 169, which means that x is equal to 13. In number 2, we have 10 as the hypotenuse because it's across from the right angle again. So we're going to have 10 squared equals y squared plus the square root of 51 squared. Now, the square root and the squared are opposites, so they cancel each other out, and we're left with 100 equals y squared plus 51. So I'm going to subtract 51 from both sides. 49 equals y squared. Take the square root, and we get that y is equal to 7. In number 3, we need to find MA. Well, across from the right angle is 9, so that's our hypotenuse. 9 squared equals z squared plus 6 squared. So we get 81 equals z squared plus 36. When I subtract 36, I get 45 equals z squared. When I go take the square root this time, 45, when you take the square root, you get a decimal. So instead of putting it as a decimal, we're going to break down our radical. So we would get 3 root 5. Number 4, find ON and OW. So we're going to put a variable by each of those. So ON I'm going to call X, and OY I'm going to call, or OW I'm going to call Y. So first I need to look for a triangle that has 2 sides in it with numbers. So we're going to use triangle SON first, and we're going to solve for X. So 15 is across from the right angle. 15 squared equals 9 squared plus X squared. So we get 225 equals 81 plus x squared. Subtract 81 from both sides, and I get 144 equals x squared. When I take the square root, I get that x is equal to 12. So now I can use that 12 into the next triangle. So now I have a triangle that has a side of 12, a side of 18, and a y. So to solve for this, notice that if it's a right angle, the angle next to it's also right, which makes 18 the hypotenuse. So 18 squared equals 12 squared plus y squared. So we get 324 is equal to 144 plus y squared. We can subtract 144 from both sides. 180 is equal to y squared. Now when I take the square root of 180, that gives us a decimal. So we need to break down our radical, and we get 6 root 5. Number 5, find RA and IN. So in this case, both triangles have 2 sides, so it doesn't matter which triangle we start with, so I'm still going to start with the one on the left. So to solve for x, we have a right angle there, so x is our hypotenuse. X squared equals 6 squared plus 8 squared. So we get x squared equals 36 plus 64. X squared equals 100, which means that x is the square root of 100, which is 10. And in our other triangle, we have 8, 14, and y. So 14 is across from the right angle. 14 squared equals 8 squared plus y squared. 14 squared is 196 equals 64 plus y squared. So when I subtract 64 from both sides, I get 132 equals y squared. So I get that y equals the square root of 132, which I need to break down that radical into 2 root 33. Number 6, the three sides of a triangle are x plus 3, x plus 10, and x plus 12. So whenever I take x and I add the largest number to, that's going to be my hypotenuse. So I have x plus 12, and the other two are just going to be the legs. So make sure that we're squaring each part. So x plus 12 squared equals x plus 3 squared plus x plus 10 squared. Now, in this problem, you cannot distribute your exponent. Instead, you're really having to distribute this out. So it's really x plus 12 times x plus 12, which would get us x squared plus 12x plus 12x plus 144 equals, then I have x plus 3 times x plus 3, which gets us x squared plus 3x plus 3x plus 9. And lastly, I need to multiply out x plus 10 times x plus 10. So I get x squared plus 10x plus 10x plus 100. So to make this more manageable, I need to combine my like terms. So on the left-hand side, I get x squared plus 24x plus 144 equals 2x squared plus 26x plus 109. Now, I notice that both of them have x squares, but there's a 2x squared, which means this is going to be a factoring problem. So I'm going to move everything to the 2x squared side because that's the larger side. So I'm going to subtract everything on this side because they were all positives, and I get x squared plus 2x minus 35. So now I factor what multiplies to negative 35 and adds to 2, x plus 7 and x minus 5. So we get x equals negative 7 and x equals 5. Negative 7 won't work because if we put it into this side, x plus 6, we'd get a negative side length. Pythagorean triples. So Pythagorean triples are 3 whole numbers, which means no decimals and no radical, that simplify to the Pythagorean theorem c squared equals a squared plus b squared. Make sure that the numbers also make triangles. So in number 1, this is not a Pythagorean triple because it has a decimal with 12.6. 8 is not a Pythagorean triple because it has a radical. Number 9, so this one looks promising because it has all whole numbers, so now we need to try it in the Pythagorean theorem. So 41 squared is 1,681, and then we have 9 squared plus 40 squared, which is equal to 1,641, which means that yes, this is a Pythagorean triple. Now, number 10, we have to be careful because although these are 3 whole numbers, this does not form a triangle because 8 plus 6 is only 14, and it has to be greater than 15, which it's not, because 14 is actually smaller than 15. So we would say no, not a triangle. The last thing we're going to look at is classifying triangles. So we can use the Pythagorean theorem without having angle measures to classify our triangles. So we have a right triangle if our largest side squared is equal to those two smaller sides squared and added together. So in this case, we had a triangle that was 3 or 5 squared was 25. 3 squared plus 4 squared is also 25. So this would be a right triangle. An acute triangle means that the legs squared are going to be greater. So in this case, 9 squared is 81, but when we squared and add the legs together, we got 89, which was the larger number, which means we had a less than sign. So anytime it's a less than sign, it's acute. And anytime it's a greater than sign in the middle, it's obtuse. So let's practice with a couple of triangles. So in the first one, we have 15 squared, which is the largest, and then we have 9 squared plus 12 squared. So we get 225 is equal to 225. We're just using a calculator to type this in. So this would be a right triangle. Make sure that you're doing the two sides separate. Then we have 16 squared, and we have 7 squared plus 12 squared. So 16 squared would get us 256. And then we have 7 squared, which is 49, plus 12 squared, which is 144. It gets us 193. Well, since my hypotenuse squared is larger, this is an obtuse triangle. And in 13, my largest side is 13, so 13 squared, and then we do 8 squared plus 11 squared. So 13 squared is 169, 8 squared is 64, 11 squared is 121. So we have 85, which means my hypotenuse squared is smaller, so this would make an acute triangle.